The United States is by far the most famous country in the world. But what makes the US so famous? Attractions such as the Mount Rushmore or the four gigantic sculptures depicting the faces of the US presidents, George Washington, Thomas Jefferson, Abraham Lincoln, and Theodore Roosevelt were carved, and many more. Hey, I'm Mini Santikuyos, and today we will explore the rocks of the United States. The richly textured landscape of the United States is the product of plate tectonics, weathering, and erosion. Over our planet's 4.5 billion year history, tectonic upheavals and colliding plates have raised great mountain ranges, while erosion and weathering have eroded them. Even after many millions of years, records of Earth's great upheavals remain imprinted as textural variations and surface patterns that characterize distinct landscapes or provinces. There are 12 main geological provinces in the United States: Pacific, Columbia Plateau, Basin and Range, Colorado Plateau, Rocky Mountains, Laurentian Upland, Great Plains, Interior Highlands, Appalachian Plateaus, Atlantic Plain, Alaskan, and Hawaiian. Pacific is one of the most geologically young and tectonically active in North America. The Pacific province straddles the borders of many of Earth's shifting plates, providing the massive forces needed to create the sweeping arc of mountains that stretches from Alaska to the southernmost of South America. The active and often lethal volcanoes of the Cascade Range, as well as the young, steep mountains of the Pacific border and the Sierra Nevada, are all part of this province. The Cascade volcanoes describe the Pacific Northwest portion of the Ring of Fire, a fiery ring of volcanoes that encircles the Pacific Ocean. As if the Ring of Fire's volcanic dangers weren't enough, it is also known for its frequent earthquakes. If we could cut deep through the Earth from the Pacific Ocean to the Pacific Northwest, we might see something like this. A thick oceanic plate plunges under the North American plate beneath the Cascades, a phenomenon known as subduction. High temperatures and pressures cause water molecules trapped in solid rock minerals to escape as the oceanic slab sinks deep into the Earth's interior underneath the continental plate. Water vaporizes into the pliable mantle above the subducting layer, melting some of it. This newly created magma rises to the Earth's surface and erupts, creating the Cascade Range of volcanoes above the subduction zone. While the Cascade Range first appeared 36 million years ago, the main peaks that rise up from today's volcanic centers were formed within the last 1.6 million years. Are there going to be more eruptions in the future? New Cascade volcanoes will continue to rise as long as the subduction also continues. Despite the fact that the Sierra Nevada and Cascade Ranges form a virtually continuous barrier along the western edge of the United States, the Sierra Nevada's rocks are mostly granitic rocks that formed during the Mesozoic era, when dinosaurs roamed the Earth through 6 steps. Due to plate tectonics, the oceanic crust collides with the heavier continental crust and slides below it. As the oceanic crust begins to melt, magma rises up to form volcanoes on the surface. As the magma cools, it becomes a granite batholith beneath the surface. As the softer sediments erode, they expose the granite. During the Ice Age, glaciers scour the granite as they advance and retreat. Glaciers follow the ancient stream beds to carve out wide U-shaped valleys, such as Yosemite Valley. The Columbia Plateau province is surrounded by one of the world's largest lava accumulations. It covers over 500,000 kilometers squared of the Earth's surface. The topography is dominated by geologically young lava flows that inundated the countryside at breakneck pace in the last 17 million years. Evidence suggests that some concentrated heat source is melting rock beneath the Columbia Plateau province. They discovered that the youngest volcanic rocks were located near the Yellowstone Plateau, and that the older the lavas were as they traveled west. The steaming fumaroles and explosive geysers are ample evidence of a concentration of heat beneath the surface. Does this mean that the hotspot is moving beneath North America? No, the hotspot is probably quite stationary, but the North American plate is moving over it, creating a superb record of the rate and direction of plate motion. The Basin and Range province is distinguished by its topography, which alternates steep climbs up elongated mountain ranges with long treks through flat, dry deserts. This basic topographic pattern stretches from eastern California to central Utah, and from southern Idaho in the state of Sonora in Mexico. During the Paleozoic era, the Great Basin amassed bedrock thousands of feet thick, but it took the forces of intense heat from the Earth's mantle and dozens of active faults to create the unique basin and range topography seen today. During the Tertiary period, volcanic eruptions spewed lava and ash across the Great Basin, creating volcanic fields. At the same time, intense heat from the Earth's mantle forced the crust to stretch and thin over a vast area, a process called rifting. The crust also swelled upward thousands of feet, creating a blister-like dome with some of the thinnest crust on Earth. Over time, the east-west stretching of the crust cracked the dome, producing north-south trending faults. Upthrust edges became mountain ranges, and downward edges became valleys. The Great Basin landscape was transformed into a distinctive pattern: basin, range, basin, range. Most precipitation in the Great Basin falls in the form of snow that melts in the spring. Rain that reaches the ground or snow that melts quickly evaporates in the dry desert environment. Some of the water that does not evaporate sinks into the ground to become groundwater. Numerous geologists have been captivated by the sculpted elegance and dazzling colors of the Colorado Plateau's sedimentary rock layers. This is a vast area of plateaus, mesas, and deep canyons, the walls of which reveal rocks ranging in age from billions to a few hundred years. The famous rock formation is the Grand Canyon. Ancient oceans filled this area from a billion years ago to as recently as 80 million years ago. The water would rise and fall again, depositing sand, mud, and ancient seashells that compressed them into a rock, piling a layer upon layer, turning the Earth's crust into a colorful layer cake waiting to be cut. The Rocky Mountains developed during a time of extreme plate tectonic activity that formed much of the rugged landscape of western North America. From around 170 to 40 million years ago, 3 big mountain building episodes reshaped the West. The growth of the Rocky Mountains has been one of the most perplexing of geologic puzzles. Normally, mountain building is focused between 200 to 400 miles inland from a subduction zone boundary, yet the Rockies are hundreds of miles farther inland. What geologic processes are responsible for the formation of mountains on this scale? While geologists continue to gather evidence to explain the rise of the Rocky Mountains, an odd subducting slab is most likely the response. An oceanic plate sinks at a moderately high angle at a typical subduction zone. Above the subducting plate, a volcanic arc forms. The angle of the subducting plate may have been greatly flattened during the formation of the Rocky Mountains, shifting the emphasis of melting and mountain formation far further inland than is usually predicted. The shallow angle of the subducting plate is thought to have increased friction and other interactions with a thick continental mass above it. Massive thrust pile sheets of crust on top of each other, resulting in the incredibly broad and high Rocky Mountain range. Every continent has a core of very ancient metamorphic rocks. The Superior Upland Province is the southern extension of the Laurentian Upland Province, which is part of the Canadian Shield nucleus. The basement rocks of the Laurentian Upland Province were metamorphosed about 2,500 million years ago during the Canadian orogeny, a mountain-building collision of tectonic plates. The superior upland rocks are mainly Precambrian metamorphic rocks with overlying Paleozoic rocks covered by a thin veneer of glacial deposits left behind when glaciers melted at the end of the Pleistocene Ice Age. The interior plains are a vast area that spans North America's stable core. Several small continents collided and welded together over a billion years ago, during the Precambrian period. Throughout the Paleozoic and Mesozoic eras, the largely low-lying interior plains area was relatively untouched by the mountain-building tectonic collisions that afflicted the continent's western and eastern margins. A Devil's Tower, a steep-sided igneous body and probably an erosional remnant of a volcanic neck, can be found in the Black Hills of South Dakota around the interior plains. It is composed of magma that solidified at a shallow depth below the surface. The columns joints that split the monolith are an amazing feature of Devil's Tower. The majority of the columns are five-sided and range in height from 6.5 to 8 feet at the base to around 4 feet at the top. The interior highlands' ancient eroded mountains are surrounded by the nearly flat-lying sedimentary rocks and soils of the interior and Atlantic Plain provinces. The rugged outcrops that make up the heart of the Washita Ozark Highlands are Paleozoic age carbonate and other sedimentary rocks that were originally deposited on the seafloor, as opposed to the relatively young rocks that distinguish neighboring provinces. These ancient marine rocks have been twisted by folds and faults in the Washita Mountains. Big Spring is the largest spring in Missouri. This spring is one of the largest springs emanating from Paleozoic limestone bedrock, the Ozark Plateaus province. The Appalachians are ancient mountains. An examination of the rocks exposed in today's Appalachian mountains reveals elongate belts of folded and truss-folded marine sedimentary rocks, volcanic cracks, and slivers of ancient ocean floor. NASA image of the Appalachian Valley and Ridge Province. These rock layers were folded during the series of continental collisions that formed the Appalachians during the Paleozoic era. Much more recent, uplifts and erosion produced the landscape we see today. The ridges are made up of erosion-resistant sandstones, the green in image, while the valleys are made up of limestone and other less resistant rock layers, the purple in image. Atlantic Plain is the flattest of the provinces. It stretches over 2,200 miles in the length from Cape Cod to the Mexican border and southward another 1,000 miles to the Yucatan Peninsula. The Atlantic Plain slopes gently seaward from the inland highlands in a series of terraces, continuing far into the Atlantic and Gulf of Mexico. It forms the continental shelf. Alaska contains many geologic terrains. Noatak, Cape Krusenstern, Gates of the Arctic, and Kobuk Valley all lie in the northern mountain belts and coastal plains. Bering Land Bridge, Yukon-Charlie rivers, and a portion of Denali exist within the plains of the center of the state. The majority of Denali, Aniakchak, Katmai, Alagnak, Lake Clark, Kenard Fords, Wrangell St. Elias, Glacier Bay, Klondike Gold Rush, and Sitka lay within the southern mountainous belts, which borders the Gulf of Alaska and runs out along the peninsula. The islands of Hawaii are a series of shield volcanoes that have built up from the ocean floor. Some of the islands are composites of extinct volcanoes, while Maui's Haleakala and 4 of the Big Island of Hawaii's volcanoes, Mauna Loa, Loihi, Hualalai, and Kilauea, have erupted in the past 2,000 years. Shield volcanoes are the result of multiple eruptions, most of which have produced fluid basaltic lavas, which flow and harden. Due to the low viscosity of these lavas, the flows are relatively thin and travel far, building up slowly to produce a volcanic profile like that of a shield lying on the ground. This is the geological map of the United States of America. As you can see in the west coast, the coast ranges of the Pacific are mostly made up of metamorphic rocks. The Columbia Plateau are made of red color, the igneous volcanic. The cream color is the Colorado Plateau that is made up of sedimentary rocks. The interior or Great Plains are covered with light gray, which consist of metamorphic rocks, specifically the schist. The Laurentian is mixed with igneous and sedimentary rocks, just as the coastal or Atlantic Plain, mostly made up of sedimentary rocks. This is the geological map of Alaska. The map is covered with different shades of colors with a vibrant red and green, and some igneous at the islands. This is the geological map of Hawaii. The beautiful pastel colors cover the islands, with mostly made up of igneous and metamorphic rocks, with a little bit of sedimentary rocks. We've reached the end of the discussion. Thank you for listening.